Primitives are the simplest types of variables in Java. A primitive is just a value. There are 8 types of primitives. We have byte, short, int, long, float, double, char, and boolean. The first 4 of them are used for storing integer numbers. They can each hold a number of a certain range. For example, byte can hold a number of -128 to +127. Short has an even bigger range, int has yet an even bigger range, and so does long, an even bigger range. You can see some examples of each of these primitives on the slide. For example, byte can hold the value 34, but so can short, int, and long. But byte cannot hold the value of 23,000, but short can, so can integer, and so can long, etc. The bigger the number, the less of the primitives it fits into. Let's have a look at how to create these primitives in IntelliJ. Alright, let's start by creating a byte. And we're going to call it b, and I'm going to store the value of 34 in there. This is how to do it. You specify the type, byte, you give it a name, in this case b, and I assign a value to it, in this case 34. Let's do it for the others as well. And here's a special case. If I'm going to create a long that doesn't fit in an integer, I have to tell Java I want to create a long by putting a uppercase L at the back. To be honest, a lowercase l would work as well, but if I use the lowercase l, it looks a little bit too much like a 1, especially if you have a different font. So it's always a best practice to do this with the uppercase L. This way, we tell Java that number on the screen, which is going to consider an integer by default, is not an integer, it's a long. And this is why it doesn't work without the L. Right now it says, nope, this does not fit into an integer. Integer number too large. But then we put the L at the back, and then Java is like, oh, it's a long, and then it's all fine, and we can store it in the long value. So just saying that the value is going to be of type long is not enough for Java to realize that the right-hand side of the equation is actually a long as well. You have to specify this manually by putting the L in the back. Float and double are meant for floating point numbers. Doubles have a bigger range and higher precision than floats have. Here's an example of each of these numbers on the slide. Float has the value 3.2, and this can be stored in both a double and a float. The value of the double on the slide cannot be stored in both a double and a float. It's too precise to be stored in a float. Let's see how this is done in IntelliJ. So here's how to create the floats. And as you can see, we get red squigglies. And this is because, similar to line 8 where we created a long, we need to specify that it's a float. And we do this by putting the letter F after the number. And this way Java knows we just created the float. And this is how to create a double. So if I'm going to be creating a floating point number, it's going to assume it's a double by default. So I can store 3.2 in a double like this, but I cannot store it in a float like this. And this is because the default assumption of Java when it sees a floating point is double. More details on this later. So I can store a number this precise in a double. Then we have char. Char is holding a Unicode character. It can also hold a numeric value ranging from 0 to somewhere in the 65,000s. But it will translate that to the corresponding Unicode character. It can, for example, hold an A. Here's how we can create a char in Java. So we give it the type char, and then we just store some character between single quotes in there, and that's one way to create a char. We can also put a number in there, and in that case it needs to be smaller than 65,535, but bigger than 0. I cannot store a negative number in a char. The last primitive we need to talk about is the Boolean. Boolean can only hold true and false. This is a great data type for storing yes/no values. If the answer would be yes, we would store true inside the Boolean value. And here's how to create a Boolean in IntelliJ. You give it a type Boolean, we give the name B1, and I did not call this one B because we already have a B on line 5 and we cannot have two variables with the same name in the same scope. And I gave it the value true. Please mind there's no quotes around true. If you try to do that, it will not work. Let's explore the sizes of these different primitives in the next video.